go, guide, go, control, go, Delcom, go, Ginseng, go, Econ, go, Surgeon, go, Capcom 1, go, continue PD.
Okay, so welcome back to the garage, and I'm just going to do a quick video today to talk about how you can easily check, well, maybe not easily, but how you can readily check to see that your valve timing is correct. The valve timing, of course, is related to the crankshaft position. So the cam and the crankshaft on all four-stroke engines are, of course, tied together. On our engines, the Type 4s, they use a gear. Okay, and on the modern engines, overhead cam engines, it's about chains. And of course, there's tensioners involved. And on some of the earlier overhead cam engines, there's belts with tensioners and hardware. Okay, so meaning to say all this and that, but at the end of the day, the theory is that the camshaft has to be running in the correct position relative to the crank in order for the valve timing to be where it needs to be at top dead center of the piston travel. It's really important now when your piston gets to the top of the compression stroke and your spark plug fires that the valves are closed, for example. So I'll include another clip here about the four-stroke principle and the position of the valves. As illustrated by this graph, we can see that the four-stroke engine turns through two 360-degree strokes for a total of 720 degrees. So basically speaking, the piston is at top dead center twice in the four strokes. And you can see it there in the middle of those two bumps between the exhaust valve closing and the intake valve opening. You're back at 360 degrees, and the piston is at top dead center at what they call the timing point. Okay, you can also use that information to see if your piston is actually there at that point. So if we use that information and rotate the engine with your ratchet on the flywheel, and as you're rotating it, you're going to start seeing the rockers move. Okay, so on our engine, on the Type 4 and on the Volkswagen engine, the Beetle 1600, the exhaust valve is at the rear and the intake valve's in the middle. And you can see the intake port directly above the intake valve in this picture. It's wide open with the two studs there. So you know that that's your intake valve, and you know that's your exhaust valve. So on the four strokes, when the exhaust valve starts to close, as it's doing here, you can see it's the rockers going up and it starts to close. And just at that point, the intake starts to open. So you'll see now the intake starting to go down, pushing the intake valve open. There she goes. She's starting to go down. Okay. So at that point, in theory, you're between the exhaust and the intake stroke. So thinking about the four-stroke principle for a moment, you know that when the exhaust valve is open, the piston's at the bottom of its stroke and starts traveling upward, and it expels the gases through the exhaust port into the exhaust pipes of the car. And as that happens, the piston travels up to the top of its stroke, and then as it gets to the top of the stroke, the exhaust valve closes. Okay, now it's at top dead center between the strokes. The next stroke is the intake valve opens. When the intake valve opens, the piston starts traveling down, and as it's traveling down, it opens more and more, and intake air is sucked in to the cylinder, fuel and air, that is, through the intake port to fill the cylinder. Okay, so between the exhaust valve closing and the intake valve opening, there's a point between there, roughly halfway between that, where the piston is going to be or should be at top dead center. Okay, so sometimes on the new engines there's some valve overlap, or performance engines have valve overlap, where that's meaning to say the exhaust valve hasn't fully closed and the intake valve already has started to open. So Porsche 911 is a good example. Air-cooled Porsche 911 is like that. Okay, so what you want to do is rotate your handle on the crank pulley until you split the difference between the two of them. So in other words, just before the exhaust valve is fully closed, the intake valve is already starting to open. So you want to kind of rock it back and forth at that point to make both valves the same height. In other words, both valves are slightly open. Okay, so the exhaust valve hasn't quite closed all the way, and the intake valve has started to open a little bit. So you get the height of the two valve retainers at the same point. And then you know that you're halfway between those two events. And at that point, the cylinder should be at top dead center. Okay, now if you remove the spark plug, and can see down there with a borescope light, or by using a screwdriver through the spark plug hole to touch the top of the piston, you can check to see if the piston's at the top. And if you use the screwdriver check, you can actually rock the engine by way of the ratchet handle a little bit back and forth to determine that your piston's at the top dead center with a spark plug through, with your screwdriver through your spark plug hole. Okay, so you drop it in there and you feel it. You feel the top of the piston. So I can feel the piston there, for example. And as I rock it a little bit past, then I can go in reverse and rock it back a little bit the other way, and then kind of check to see where my piston is to determine exactly the best, where it is top dead center. Is it at the best TDC point? Okay, so, and then when you get that piston adjusted at top dead center, then you can go down now again and look at the valves and see if it corresponds. Okay, so is the exhaust valve open the same, is the exhaust valve off its seat the same amount as the intake valve is off its seat open? If that equals TDC on the piston, you know that you don't have a problem with your valve timing. So you can rule the valve timing out of your problem definition. So, or your problem, it's not your valve timing is what I'm saying. So you got another problem with the engine. So this way you can troubleshoot to check to see whether the valve timing is correct for the crankshaft position. It's got a lot of value knowing that for troubleshooting purposes, especially on engines that have belts and chains that may have skipped, and you're scared that they might have skipped, but you're not sure. And before spending a ton of money to change all that, chains, belts, tensioners, whatever, dismantling the engine, etc., because your engine's running rough and you think that's the problem, well, it might not be the problem. So certainly do this check to find out for sure before you spend a ton of cash. You can make this check on all Volkswagens and Porsche engines and other four-stroke engines as well. Small block Chevys, Jaguars, Lotus, whenever you're wondering about your valve timing. Okay, well, I hope you enjoyed the video, and thanks for stopping by the Retro Garage, and please leave us a like. Thank you very much for watching. Hey?